Hi everyone, welcome to the Fundamentals of SQL Server Indexes Part 2. Apologies for the delayed start that has happened due to our tool which sends out the invitation, the joining link, etc. That is delayed a bit. As I look on the left side on my laptop, the emails are still going. For whatever reason, the processing of the list is taking some time. But then all of you have already waited for 10 minutes. So yeah, we can't delay any further. So thanks for waiting, and apologies once again for starting late. Let's start with part two of this four-part series. In fact, last week when I did part one, and at the pace at which we were going and I got incredible feedback, I thought, why not break this up into four parts? And really, to cover the fundamentals, we would require maybe many more parts, but then we just can't keep doing fundamentals. We want to go up to the intermediate level and advanced level also. But because I believe fundamentals are so critical, and if you have a rock solid foundation about SQL Server indexes, it's really going to be very useful when you are tuning queries, when you are designing indexing strategies. These fundamental concepts are going to be very, very useful. So, what exactly did we do in part one? Okay, so let's take a quick look at the code. How many of you, okay, did you attend part one? I mean, in the chat window, you may just put down, like, you know, which country are you from? You could put that down, and yeah, one, that's good. If you attended part one, just type in one. Yeah, and that will just give me a good sense of. By the way, we have more than 100 people already in the webinar today. That's cool. Okay, so looks like some of you are attending part two directly, and many of you attended part one also, which is good. Okay, so those of you who attended part one, welcome once again for to part two, and those of you who did not attend part one, remember this is a free webinar, which means part one recordings are available on sqlmaestros.com. So don't worry about that right now. You please pay attention and focus on part two, but you can go back to sqlmaestros.com and check out the webinars section. You will find part one available there, which is absolutely free. Okay. And yes, while we've been talking so much, why not spend another 30 seconds and let's call this out. Which country are you from? Sorry, I forgot all of that because I was a little tensed about these invitations going on. And I can see the mails are still just a few percentage left over. Let's see how many are still remaining there to receive. Yeah, of 3,000 more, about 4,000 more. 4,000 more people are about to get the emails. Yeah. Okay, that's fine. I just have to leave it there. Okay, I'm going to call this out. So we have people from the US, from Sejak, again USA. Okay, where are the other countries today? A lot of US folks. Okay, we have people from India as usual, as always, late time. At this time, we don't get too many people from Australia or from this or New Zealand, that part, because it's pretty late there. Greece, Nigeria. Great, lovely, lovely. Global participation once again. Okay, friends. So let's do a very quick recap of part one and then continue with part two. So in part one, I started off with creating a heap. Then I explained what a heap is like. Heap illustration, nothing but random bunch of pages on the disk in no specific order, right? And then I used certain system stored procedures and dynamic management views to show you the internals of indexes, the structure, and the architecture. So we used SP help index and this DMDB index physical stats. You're going to use this so often, right? Very important for DBAs. Then we looked into what we call as the scan. When it is an index, when it is a heap, you have a table scan. This is what I showed. And then we created a clustered index. We had a brief discussion about clustered and non-clustered, but we didn't discuss non-clustered in detail, which is what we are going to do today. We talked about that clustered index is the data. You can only have one clustered index on the table because there's only one way how you can sort the data. So this is the syntax. You create the clustered index on the table and you have to choose the clustering key. I did mention that the choice of clustering key is important because a lot of things depend on whether you have a single column index key or a multi-column index key and the choice for it, because the data is going to be sorted by that. So think about running range queries. You may want to have the data already sorted in that fashion, in the fashion in which the query is going to ask for it, those kind of things. But I did also mention that that's a longer discussion, and maybe we'll do it in some other webinar. So we created the clustered index and then I explained this is what the index structure looks like. You have the root page, the intermediate level, and the leaf level. The leaf level is the data, and these are additional index pages that get added. The leaf levels are linked with each other. Each page has a previous page pointer and the next page pointer. We talked about such things, and then we again went ahead and looked into the index structure. And of course, now you're going to find more additional information about the root page, the intermediate page, so on and so forth. And then we saw that how the table scan changes to a clustered index scan. And of course, either you can have a table scan or you can have a clustered index scan. You can't have both, because the moment you create a clustered index, the heap is no more there and it becomes a clustered table. Clustered table is an informal term, so don't hold me for that. Okay, let's move forward. Now, this is where we are going to continue, and this is the point where I ended webinar part one last week at this point. So let's resume from here. All good. Let me just do a final check of this email that was going. Is that complete? I'm just curious. Okay, no, 3,000 more to go. Okay, no problem. Okay, friends. So let's do this. We have the actual execution plan turned on. I am going to run this. First, select start from sales order header. And if you look into the execution plan, you will see a clustered index scan, right? No brainer at all. And I'm sure this is crystal clear. Now, look at this one. We say select star from the sales order table where sales order ID is equal to 43659. Now, this is a clustered index seek. Now, this is where you are using the clustered index now. I mean, at least the seeking capability. Let me run this one first once more. You have this clustered index scan, jump over to the messages, and you can see that all the pages are being touched. About 800 pages, which means because it's a scanning means the storage engine, the optimizer, is touching all the pages on the disk. But that is not what you really want out of an index. You want a seeking operation, which is traversing the index from root page to the intermediate page and to the leaf level. So when you say select start from sales order header, where order ID is equal to some number, you know that clustered index is on sales order ID. Let's go and execute this. You get that one record, but to get this one record, did SQL Server scan all the pages? No, not really. If you look into the messages tab, you will see just three logical reads. Why? One page in the at the root level, one page in the intermediate level, and one page exactly in the leaf level. That gives you three pages. And this is where clustered index is being used effectively. You jump over to the execution tab and you will see a seek operation. And this is what you expected, right? Perfect. Now, whenever you are using sales order ID for the purpose of filtering, which means whenever you're using it in the where clause, you would expect the optimizer to perform a clustered index seek. But the moment you take a column on which there is no index at all, I mean, there's nothing at all on total due. On sales order ID, you had clustered index, but on total due, you do not have any index. What do you expect now? Anyone in the chat window? I know this is basic stuff, refresh it for experienced people, but a lot of good learnings for new folks. What do you expect? Don't say table scan, please. This is not a heap anymore. What do you expect? I want to fetch a few columns and I say where total due is equal to something, right? Bang on. Many of you are spot on. This is going to be again a clustered index scan. Let's go and execute this. You get that one record, jump over to the messages tab. Look at this. The entire table was touched, all the pages in the leaf level. Let's go and look into the execution plan. And right there, you have clustered index scan. Now, friends, this is where non-clustered index comes into picture. Now, clustered versus non-clustered. The first key difference here is clustered index is the table. Remember that. There's only one way how the data can be sorted, and that is why you can have only one clustered index on the table. And clustered index is the table, that's the storage. But you can have multiple non-clustered indexes. Why? Each non-clustered index is a separate storage structure. So the the structure of the index is exactly the same. All the framework and the elements that we have spoken about is the same. It's the same B tree structure. It's the same root and the intermediate and the leaf level. But because clustered index is the table, you can have multiple non-clustered indexes on one or more columns, and you can just have plain speaking, as many as you want. There is a technical limitation as to how many non-clustered indexes you can have. You can search on that, but seldom would you really require to hit that high limit of non-clustered indexes on a single table, right? I mean, that would be like, I don't know, last time that what I run was 999 or 249 or whatever that is. But yeah, you can have multiple non-clustered indexes because each non-clustered index is a separate storage structure. Now, let's do one. We are going to create a non-clustered index on this table, sales order header, and that's the name of the index, IDX total due, and we put our column index key as total due. Now, any index, clustered or non-clustered, could be a single column index or it could be a multi-column index. Like for example, here you have select subtotal and total due. I could always put subtotal also here. Like I can just put it like this, right? We could do this. We're going to discuss this in part 3 as to when, why, how would you do such things. But for the time being, let's keep things simple with single column indexes. Now let's go and create this non-clustered index. There you go. The index gets created, and let's go and look into the sales order header here. And now what you are going to see that there are two indexes. With the help of SP help index, you can see we have one clustered index located on the primary file group. We have another non-clustered index located on the primary file group. Primary here is important as to which file group the indexes belong to. Okay, just jumping off the gun, these are a lot of performance and storage considerations that we make all the time, where you have a huge table which is in one file group, but you want to, and then when you have indexes, the indexes also turn out to be huge because the tables are huge, and depending on how many columns you put in the index, your index structure could be big. Do you want to put that huge index structure in another file group, probably which is residing in another LUN, and then you have multiple spindles working when it comes to storage? Those are pretty advanced considerations when you're dealing with very large databases, right? Just wanted to call that out. Okay, so we have the non-clustered index. Now we go back and look into this same query. Now select subtotal, total due from sales order header, where total due is equal to some value. Friends, what do you expect now? Anyone? What operation will the optimizer choose? Anyone? Okay, we have people answering. Okay, non-clustered index seek. Spot on. This is what is going to happen now. So let's go and select this one and let's go and execute and jump over to the execution plan. And yes, we actually have a index seek operation happening. And along with this, you see a few other things. And now suddenly the execution plan has has a few more elements to it. Like all this while you were just seeing the select operator and the scan or the seek operation. But now, apart from the seek operation, you have a few other things. So before we move forward, let's go a little deeper into this. And this is going to be very, very useful for people who are new to execution plans. I know there are people in the webinar today who have a lot of experience with SQL Server. So this is really a piece of cake for you. I know that. But just 5 minutes or maybe 3 to 4 minutes for people who are new to SQL Server. What you have in front of you is the execution plan, which tells you SQL Server is telling you how was the query executed, right? The optimizer performed a seek operation on this index idx total u. This is a non-clustered index, and you can see we have a index seek operation. This is what you expected. Let's see how many rows did we get out of it. This arrow here will tell you that. So if I take the cursor over here, it tells me actual number of rows. It was just one, which means lovely cardinality estimation. If you look at the estimation here, 1, and you have actual also as 1, which means it was a good hit, in terms of cardinality estimation. And if you look at the result set, we were only dealing with that one row. So you get that one row out of this operator. Great. Then the optimizer is doing some lookup. There is another operator here which says key lookup. And this key lookup is happening on the clustered index. You know that clustered index is the data. It is the table. This is a separate storage structure. The non-clustered index is a separate storage structure. From this structure, the total due, right? The total due value has been pulled out, and then that value is being taken and is being looked upon in the clustered index. Why? Because you wanted another attribute. Where is that attribute? That is subtotal. Subtotal is not part of the non-clustered index. Subtotal remains in the clustered index. So you want that attribute also. So what is SQL Server doing is pick up the total due from the non-clustered index. With the help of that, look up on the base table, which is the clustered index, and fetch the matching records. You know that the matching records, when I say records, is just one record, isn't it? So if we take the cursor over here, wow, spot on. Here also you can see estimation and actual as 1. Okay, so what did you get? That one matching record. And then using this nested loop operator, it says inner join. Well, you didn't ask for any join, right? You were just fetching data from a single table. But internally, the optimizer is now dealing with two storage structures. It's dealing with this non-clustered index, which is a separate storage structure, and it's dealing with the base table, the clustered storage structure. It takes the data from these two and joins them and sends it back to the client. This is what happens. How many records are sent back? Let's take the cursor over here, just one record. And this is what you see in the result set. I want to make sure that you have understood that pretty well. What exactly is happening behind the scene now? How is the optimizer really leveraging the non-clustered index and is also utilizing the clustered table? If you want to watch the remainder part of the webinar and all the remaining demos, you can subscribe to the webinar on sqlmaestros.com and get lifetime access to the recorded webinar. All you have to do is just go to sqlmaestros.com, click on the recorded webinar section and get access to all the webinar recordings. There are many of them. Some of these webinars are free and some of them are very nominally priced. So the ones that you're interested in, you can subscribe to them and get lifetime access. Now, because there are so many webinars, subscribing to each webinar might be a bit cumbersome. So we have another option, which is SQL Maestros membership. So the first link on SQL Maestros says join. If you click on that, it will bring you to SQL Maestros membership. Things are very simple. There are two membership levels. The first level is free, where you get access to all the free webinars and all our tutorials and demos, more than 200, 300 demos and tutorials. All you have to do is just become a free member. You're paying nothing and you get access to all of them. So you don't have to go and subscribe to each webinar individually. Just become a free member and then explore the free video lobby. So if you go to the video lobby here, there is something called as free content where you get access to all of that. But then all of us are interested in advanced content, isn't it? And that is where premium membership comes into play. So the webinars that are paid, and there are many advanced tutorials and demos. If you want access to all of them, you can become a premium member and pay a nominal price, which is annual membership. Once you do that, you can explore the premium video lobby. If you go to the premium video lobby from here, or just go to the video lobby and click on premium content, you can see all the paid webinars and all the advanced tutorials and demos and get access to all of them with your annual membership. Anyway, choice is yours. There's a lot of content on SQLmaestros.com, and you can also explore the YouTube membership level as well. So you have free content on YouTube channel, and you can also join and become a member of SQL Maestros on YouTube, where you can pay a monthly fee, get access to all the paid webinars and advanced content. So in summary, you can go to SQLmaestros.com and become a member, or you can become a member on YouTube also. Becoming a member on SQLmaestros.com turns out to be a little cost effective with the annual membership in comparison to YouTube monthly membership. But anyway, choice is yours, whichever platform you wish to use. Happy SQL.